Okay, I want to talk through the word problems. I don't think I need to talk through questions 1 through 6, the problems that are already set up for you. I just want to talk through the word problems. So when I do a word problem, first thing I want to do is I want to read all the way through the problem to get a kind of a comprehensive understanding of what's going on. So a ship sails due east. So a ship is sailing from the west to the east, left to right on our screen. At one point, the bearing of a submerged rock, so bearing from due north, right, clockwise. A bearing is 45 degrees. So ship sitting down here, due north is this way, 45 degrees. The rock's over here somewhere. After the ship has sailed another 15.2 miles, the bearing is now, from due north, 308 degrees. So here's 270, so we're looking kind of northwestish. The distance of the ship from the rock, find the distance of the ship to the rock at the latter point. Okay, so let's start over. Let's draw a west, east, west line. Ship is sailing along this line. So just let's make a point where the rock is at. Rock is here. Ship is on a, or sees the rock at a bearing of 45 degrees. So we're looking somewhere around here. There's due north, looking 45 degrees and 20 minutes to the rock. Here's the ship at the beginning point. This is 45 degrees, 20 minutes. From due north towards clockwise, towards the west, 45 degrees. Okay, 15.2 miles later. So where is 15.2? I don't know. So let's kind of get this 308. If this is due north right here, 308 goes 270 plus 30 more. Yeah, that looks pretty good. So I'm going to put the ship right there. And this is 15.2. Really what we need to know is it past the rock or not? And if it's going 308 degrees, it must be, the ship must have sailed past 90 degrees straight up and down from the rock. It must have gone past the rock. I would not have known that had I not checked where this angle, this 302 degrees would be. So here's due north, 308 degrees puts this right here. I missed a little bit. You got the idea. So that is a 38 degree and 40 minute angle. So I want to find, what do I want to find? The distance from the rock to the ship at the latter point. I need this guy right here. We'll call that X. In order to know this, using the law of sine, I need to know this angle. In order to use the law of sines, I must know the side length and a side and an angle across from it. I know this side length only, so I'd have to know this angle in order to use law of sines. In order to use law of cosines, I would need to know side, angle, side, right? A squared plus b squared minus 2ab cosine c. In order to find this side length, I must know the other two. I don't know this side length. I can't use law of cosines. Well, that leaves me with the law of sines. So I have to use the law of sines. So in order to use law of sines, I can find this angle and I can find this angle if I know that angle. And that gives me enough information. I know this angle then, and I know this side. This angle from due north to due east is 90 degrees. So 90 minus 45 degrees and 20 minutes I can find. Borrow, that's a 9. Borrow 1 degree, which is 60 minutes, and I end up with 44 degrees and 40 minutes. So this is 44 degrees and 40 minutes. Now on your calculator, you could go 180 minus, and you could convert, you could convert these two angles into decimals. And you can go 44, remember how to do that? 44 degrees plus 40 over 60 minus 38 degrees plus 40 over 60. We're converting this minutes of 40 minutes into the decimal equivalent. We have 40/60ths because there's 60 minutes in a degree. This is how we would do it every time if you want to use your calculator. Okay, and so you can go ahead and do that. Type that in if you want. I'm just going to add these two together real quick. So 40 plus 40, this gives me 80 over 60. So 80 minutes out of 60, that's 1 degree and 20 minutes, right? So adding 40 plus 40 gives me 80, which is 1 degree and 20 minutes. So borrowing, or not borrowing, but raising, that becomes 45 plus 33 would be 83 degrees and 20 minutes. So these two added together are 83 degrees and 20 minutes. Taking 180 and subtracting that, borrow 179 and 60 minutes gives me a 40, and 179 minus 83 gives me 6. 17 minus 8 is 96. This angle up here is 96 degrees and 40 minutes. Okay, and if you don't like what I just did here, type that into your calculator. You should get 96, well, you'd get 96.666666, etc. You can convert that then into degrees, minutes, seconds if you want, or leave it as 96 degrees or 96.666666, etc. Okay, I need more room. I'm going to get rid of all this mess. Excuse me. Sorry, my microphone is right by my mouth, so when I cough, I'll try to cough sparingly. All right, so here's what we got. Law of sines, 15.2 over the sine of 96 degrees 40 minutes equals x, what I'm looking for, over the sine of the side or the angle across from it, which is 44 degrees and 40 minutes. Once we get here, based upon what we've been doing lately, we're okay. 15 times, I'll just go ahead and type in or write what we're supposed to type in. Sine of 44, we're doing plus 40 over 60, or you're going on the Inspires, you're going to go over that tab if you want to, but 44 over 60, that's pretty easy to type in versus going over to that tab and, or not tab, but that key and trying to find that degree, minute, second button. That's totally up to you, whichever one you want to do. I would just do 40 over 60. Pretty quick to type it in. I'm going to cheat. Answer to that should be 10.6, 10.76, 10.76 miles. Okay, so there's the work that I did on paper and on the answer key. Okay. Question 8. Read through the problem, get a feel for it. The bearing from Pine Knob Fire Tower. So we have Pine Knob Fire Tower sitting somewhere out here to Colt Station Fire Tower is 65 degrees. Now it's not a bearing like without a direction given. Now we're told what the bearing relationship is, I guess. It's east of north. So now 65 degrees east of north. So here's north, 65 degrees east. Well, that's west. We're going east of north. I think I said west when I was up here above. Sorry. So here's Pine Knob. I'm going to call that PK. Pine Knob. Here is due north. We are going 65 degrees east. So Colt Station must be sitting up here somewhere. Cruise up there. Okay. A fire spotted by rangers in each tower has a bearing of 80 degrees east of north from Pine Knob. So here's north. 80 degrees now puts me, this is 65. So 80 degrees puts it somewhere over here. Okay, I'm not going to draw where because I don't know where at. I'll just kind of go off in this direction where this is 15 degrees because this is 65 and the fire is 80 degrees. Okay, and from Pine Knob, 70 degrees east of south. So from Colt Station, here is south, 70 degrees east. So here's east of south. So there is 90 degrees east of south, 70 degrees somewhere right in here. So cruising along this guy here, cruising or continuing that guy down here. Here's my fire. And this is 70 degrees east. This is east over here, east of south. Here is 80 degrees east of north. If this was 65 to the station, and then it's another 15 more to the fire. Okay, what do we know? The distance between the two towers is 30. That's the only side length we know. I'm probably using, not probably, I am using law of sines. I have to. Law of cosines requires two sides, at least. You could have all three, and then you're finding the angle with law of cosines. I don't have a side angle side. I'm using the law of sines. Here's my 30. I have to know this angle over here. And really, I have to know them all because I want the distance from the fire to each tower. So I have to know this distance and that distance. I need all the angles. Okay. How in the world are we going to find all the angles? So here's what I know. I know that this is 70, right, from here to here. We know that these two lines are parallel. This is north-south, looking north, but it's a north-south line. This is a north-south running line. They're parallel. Back from geometry, alternate interior angles form a Z, and they are congruent. These two angles are congruent. So this is 65 degrees. Grand total of 70 plus 65 is 135. So this is 135. 135 plus 15 gives me 150. Makes this angle over here 180 minus that, or 30 degrees. I'm going to erase this right here so I can put in the 130. Okay, so now I know all three angles. I can find whatever side I want. So the ratio of 30, the side length, to the sine of 30, the angle across from it, equals the side length from, let's say, PK, the pine knob, to the fire, I'll call X, over the sine of the angle across from it. Cross multiply 30 times the sine of 30 divided by the sine, 30 times the sine of 130 divided by the sine of 30. Wow, way too many 30s in here. And I'm just going to, at this point in time, scroll down so you can see my written work. What did I do wrong? Oh, that's not 130. That's 135. I said it right earlier and wrote it wrong. So hopefully you caught my mistake and you're yelling at me through the TV screen. It says even 135 sitting right there. I just can't copy correctly. So that's 135. That's 135. That is a big, common, it was a better word, not big, a very, very common mistake is just not copying the problem down correctly, not being careful. Speaking to myself. Okay, so there's a calculation I just had, or the equation I just had up there. When you do that, you should get 42.43. Now switching to the other one, calling that y, it's going to be 15, or the sine of 15 over y equals the same sine of 30 over 30. Remember, it doesn't matter which one's on top, but whatever's on top over here must be the same over here. In this problem up here, I wrote it side length on top, angle on the bottom. Here I wrote sine on, or the angle on top, and the side length on the bottom. It doesn't matter. As long as from one side to the other side of the equal sign, you are consistent. Okay, so then here's the other ratio we're setting up. The 30 times the sine of 15 divided by the sine of 30 should give you the y. 30 times the sine of 135 divided by the sine of 30 should give you the x. Make sure you answer the question. Find the distance from the fire to each tower. It doesn't say solve for x and y. Answer the question. Jump back over here. From the pine knob to the fire is 42.3, etc. Okay. Number 9. This one, sorry, set up, but we need to be able to fill in the right angles. Straight road makes an angle of 20 degrees with the horizontal. So this is letter A, and we're calling that 20. Well, let's find an angle that's more meaningful. I don't really care about that angle. But this angle down here is also 20 degrees because these are parallel. It says with the horizontal. Any horizontal, the road's making an angle measure of 20 degrees. So this little guy down here is 20 degrees from the road to the horizontal. This is 20 degrees. It's not angle B. They're calling angle B this whole entire angle. Just that portion of it. Just this portion right here. Okay. When the angle of elevation B of the the horizontal to the sun is 54 degrees. This is a 6-foot shadow. So I'm assuming that this is what they're calling the shadow. So the sun's over here, so the shadow's going to be on this side, right? Shadow's not going to go uphill if the sun's over here. The shadow's going to be on this side. So I'm going to call this whole entire length the shadow, where that is the tip of the shadow. Okay? It doesn't matter. We can call that the tip of the shadow, but this would be a 20-degree angle and so on. I might as well use what we have drawn right here. There's the length of the shadow. Okay, approximate the length of the pole. This is 54 degrees from here to here. We already said this is 20, so I'm gonna get rid of that 6, put it in a different location because I want that to be my 34 degrees. 54 minus the 20. 54 from the sun's angle of elevation to the horizontal is 54. We already said this is 20, leaves that as 34. This side length is 6. I guess I'll still try to fit it in there. And we are looking for the height of the pole. I'll call that x. Okay, now, again, it's law of cosine, law of sines. We only know one side length. I need this angle up here. I need this angle down here. So we need to think through how in the world are we going to do that? I'm just going to, this vertical pull, right? Vertical pull. It's going straight up and down. So if I draw this vertical pull down to the horizontal, right? Because it says it makes a 20-degree angle with the horizontal. Then this must be 90. And if this is 54, looking at this big triangle, these angles add up to 180. There's 90 already. So these two add up to 90. 54 minus 90 makes this angle up here 36 degrees. Okay, if this is 36 and this is 6 and this is 34, it's a simple 6 over the sine of 36 equals x over the sine of 34. Just a straightforward law of sines. Sine of the angle over the side opposite equals the sine of the angle over the side opposite, or vice versa. Cross multiply, 6 times the sine of 34 divided by the sine of 36 should give you the x. And again, going down to the work I did earlier on the review worksheet, answer key, there's the same setup, and that's what you should get. Okay, last one. This one, we already have a picture, so you probably don't even need me to do this one because there's already a picture. We're looking for QR. There's two sides. Now I can use the law of cosines. It's side, angle, side. So now I can use the law of cosines. This will be my C. Yeah, I get it. It's the S, but this will be my C in the C squared equals A squared plus B squared. So C squared, or you could say, like I do on the answer key, QR squared, however you want to label it, equals 35 squared plus 43 squared 3 minus 2 times 35 times 43 times the cosine of 64. Make sure you have cosine here and not sine. Make sure you have sine here and not cosine. Helping people earlier, that was definitely one of the common mistakes. Okay, so I'm going to jump down here. If you do that, you should get that the length of QR is 41.9 meters. Okay, what's the measurement of angle Q? Looking at angle Q, I want this angle over here. So now you have two options. You have this side over here now. I have three sides. I could do the law of cosines, call this capital C, which would make this little c. Remember in the law of cosines, this is the angle I know, or it's the angle I want. And this side length, C, is the side across from whatever I know or I'm looking for. So if I want to use law of cosines, this would be capital C, and this would be little c. This would be A, this would be B. So remember I said, let me grab what this one is, 41.9. So C equals 41.9. So remember I said, try not to use something you calculated. Try to use something that was given to you. I can't. I have to use this 41.9. Whether I'm using law of sines or law of cosines, it doesn't matter. I have to use this 41.9 in order to get angle Q. So hopefully this is right. Okay, so I'm going to use law of, what did I use on the answer key? I use law of sines. Let's use law of cosines because I use law of sines on the answer key. So I'm going to go 35 squared equals 41.9 squared plus 43 squared minus 2 times 43 times the 41.9, 1.9 cosine of some angle Q. Subtract 41.9, subtract 43 squared from 35 squared. Take that answer, divide it by this mess here, and you get your answer of Q equals cosine of that angle. I'm going to hit pause and do that real quick in case some of you are doing it that way. I'll hit pause and do that. When I do that, I get to write, come on, I get 0.66037, etc. Take your calculator, go inverse cosine of the answer, and I get 48.67 degrees. Cruising down here, 48.66, but I went to the nearest decimal or nearest hundredth. I think I must have or dropped something on that one. Anyways, then we're going to take our 0.67 decimal we have and divide it by, or subtract the 48, divide by, or times by 60, subtract the whole number, times by 60. And if we did that, we would get this angle measure. To the nearest degree, which is what was asked, it'd be 49. To the nearest hundredth, it'd be this. Degrees, minutes, and seconds, it would be this. question asked for the nearest degree, so actually, technically, this is the correct answer. But be able to do both of these. Okay, that is the law of sines, law of cosine review word problems. Hope it helped.